This video is going to cover the second part of Chapter 12, the risk, return, and capital budgeting. In this video, I'm going to cover the CAPM model and the capital budgeting decision. So first, let's get started with the market risk premium. We talked about the risk premium in Chapter 11, and the market risk premium is just the difference between market return and the return on risk-free treasury bills. So when you are investing in some asset that embeds some risk, we are requiring a higher return, which is known as the risk premium. And the market risk premium is just the difference between the market return and the return on the treasury bills, which we assume to be risk-free. Okay, and the CAPM model is the theory of the relationship between risk and return, and it says that the expected risk premium on any security equals its beta times the market risk premium. Okay, we use symbol Rn as the return of the market portfolio, and we use Rf to stand for risk-free rate, and the market risk premium will be Rm minus Rf. Okay, that's the definition of the market risk premium. And we use symbol R to stand for the return or the expected return of any asset. Then the risk premium on any asset will be R minus Rf. Okay. The CAPM model says the risk premium on any asset, R minus Rf, equals to the beta multiplied by the market risk premium. So it says R minus Rf equals beta multiplied by Rm minus Rf. Or the expected return here, R here, equals, if we move the Rf to the other side, we have the Rf plus beta multiplied by the market risk premium, which is Rm minus Rf. Okay, let's look into an example. Suppose the return on the stock market is 10%, and the risk-free rate is 3%. What's the risk premium for a stock that has a beta of 0.5, and what's the expected return of the stock? So first, we can calculate the market risk premium, which is the Rm, the stock market return 10%, minus Rf, the risk-free rate 3%. So 10% minus 3% is 7%. Then we need to calculate the risk premium on any asset, okay, which is R minus Rf. However, the CAPM model also says the risk premium on any asset should equal to the beta times the market risk premium. So we know the stock beta is 0.5, and we know the market risk premium is 7%. So the risk premium should equal to this, equal to 0.5 multiplied by 7%, which is 3.5%. Okay, so in other words, R minus Rf equals the risk premium on the asset, which is 3.5%. And then, okay, if we need to calculate the expected return, we can plus adding the Rf to both sides. So the expected return R will be equal to 3.5% plus the risk-free rate 3%, which is 65%. Or you can just use this formula. Okay, it's the same thing I'm talking about. Use this formula to get the expected return is 6.5%. Okay. So this is the CAPM model, and there is another way to write the CAPM model and the symbol. So we use R, the capital R, as the return on any asset. We use Rf as the risk-free rate plus beta multiplied by the market risk premium, which is Rm minus risk-free rate Rf. Okay, so this is like just a different way to write it. If you see this, it's the CAPM model, you need to recognize it. Okay, next, we can actually plug in the thing into the graph. So for the x-axis, we have in beta. Okay, for the y-axis, we have expected return for any stock. The slope of the curve is determined by the market risk premium. Okay, remember the market risk premium is determined by the market. Okay, it's the market portfolio return minus the risk-free rate. is determined by the market. What we can do is we can choose different stocks, or we can construct different portfolios that has different beta. So we can change beta, but we cannot change the market risk premium. Okay, say for example, if we choose a stock Y that has a beta of 0.2, and the market risk-free rate is 3%. Okay, so we can use this CAPM model and calculate the expected return of Y is 4.4. If we choose a stock with a higher beta, say for stock X, there's a beta of 0.5, we can calculate the expected return will be 6.5. Okay, and if we choose the beta equals 1, okay, as the market portfolio, then the expected return is 10%, okay, as the market return. Okay, and we call this line the security market line. Okay, so this is like represents the CAPM model into the graph. Okay, the security market, the security market line equation is just the risk-free rate. Okay, which is the intercept here on the y-axis, plus beta, okay, which is Ux, and Rn minus Rf, okay, the market risk premium, which is actually the slope of your curve, okay, and this, the Rn minus Rf, is more or less determined by the market. The variable you can choose to vary here is actually the beta. Ux is actually the beta that you can pick up different stocks to get different beta. Okay. So let's just look into some examples here. So if you remember in the first part of video, we talked about a company called US Steel. It has a very large beta, which means it's very sensitive to the market. Because it has a large beta, it also says it has a high expected return. Okay. Because using the CAPM model, okay, if you have a large beta, you are forced more to the right-hand side of the graph, and the expected return will be higher. Okay? And similarly for the PG&E, if your beta is small, your expected return will also be smaller. Okay. So this is how the beta, okay, is related to the return. Okay. And remember, the CAPM is just a model or a theory, and there are always ways to test the theory. The theory is not always correct. In practice, we have the market, the stock market, determine the stock price, and we can use the real data to test our model. Okay, say we can find the portfolio beta, where we have investors from different portfolios. We can find the beta for those portfolios, and we can find the return for those portfolios. We plug into the graph, okay, and we see whether it's fitting into this SML line or it's far away from this line. Okay, so this is like a way to test the CAPM theory. And I'm not going to go through all details here. There are also different challenges for the CAPM model, and there are a lot of testings due to test the CAPM, to testing this CAPM model. Okay, and the takeaway message here is what the CAPM model says is the return, okay, is connected to the risk. The higher the beta, okay, the more sensitive you are to the market stock change, the higher return you are supposed to get. Okay, so this is a formula that nicely connects the beta to the return. Okay. And if you are interested, you are very welcome to read more into the different testings of the CAPM model. Next, I'm going to talk about the capital budgeting and the project risk. Okay. The project cost of capital depends on the use to which the capital is being put. So as a result, it depends on the risk of the project and not the risk of the company. A company can invest in different projects. Some projects are more riskier than others. So for those projects that are riskier, it will require a higher return because there's a higher risk premium. Okay? And when we consider the company cost of capital, it's the opportunity cost of capital for investment in the firm as a whole. Okay, so when we say the company cost of capital, it's we're considering the company as a whole. We are not talking about the project cost. And the company cost of capital is the appropriate discount rate for an average risk investment project undertaken by the firm. Okay. These are just definitions, and let's look into some examples that will help you to that will make more sense. So suppose based on the CAPM model, ABC company has a cost of capital of 17%, okay, which is the risk-free rate of 4% plus the beta of 1.3% multiplied by the market risk premium of 10%. Okay, and so here it tells you the beta of this company. It tells you the market risk premium of this company and tells you the risk-free rate. And then a breakdown of the company's investment projects is listed below. And when evaluating a new dog food production investment, which costs of capital shall be used? Okay, so it tells you there are 3 different projects. The first is the nuclear part manufacturer project. The beta is 2.0. The compute hard drive project has a beta of 1.3, and the dog food production project has a beta of 0.6. Okay, and why they are different? Why there are different beta here is because a company have different projects. Some projects say the nuclear parts manufacturing is more riskier than the dog food production. Okay, so because it's more riskier, it's requiring a higher return. Okay, it's also having a higher risk beta here. Okay, so the average beta is we can calculate is 1.3. Okay, because the company has an average beta of all its assets, and the beta of the company is 1.3. So which beta we're supposed to use to calculate for this specific project? As I said, there is a beta associated with the company and there is a beta associated with each project. When evaluating a project, you need to use the beta associated with this project. So when evaluating the new dog food project, you need to use the beta here, the beta associated with it, which is 0.6. Okay, it's a small beta saying this project is kind of very stable, generates a stable cash flow, so it's not very risky. Okay, next, this is the beta we are supposed to use, and we can use it to calculate the return. So the risk-free rate, remember the earlier CAPM formula tells you how to calculate the return for the asset or for the return for this project is the risk-free rate. Okay, 4%. We can see here from the from this formula, it gives you how they get the cost of capital for the company. The risk-free rate is 4%. Okay, the beta we should use is 0.6. Okay, so beta is 0.6, and the market risk premium is 10. Okay, it's also given here. So 4 plus 0.6 multiplied by 10, that gives you a return on this project of 10%. Okay, so this 10% reflects the opportunity cost of capital on an investment given the unique risk of the project. Okay, if you calculate the return for the nuclear parts manufacturing project, you will get a higher return because higher expected return because you are having a higher beta. Okay, and think about this return here are when you are issuing bonds. Remember, there is a discount factor or discount rate you are using to discount the cash flow of bonds. If you are raising money for different projects, what's the discount rate you are going to use. Okay, this should be associated with the risk level of your project. So actually, you can use this CAPM model to calculate the discount rate for your project specific cash flow. Okay, so this is how things are connected together, and I hope you will find my class helpful, and that's all for the chapter 12.